Hey guys, today I wanted to talk about another battery build that I'm going to be doing. So I decided to purchase some batteries from 18650batteries.com and build 3 separate batteries of mine. So I'm going to be building 48 volt batteries. These are the in-house brand for 18650.com. So let's just open them up and take a look at the actual batteries. They're in a nice little case here. And I'm just going to pop them open. So these are 18650 batteries. They are 2500 milliamp hour, 20 amp, and each one is 9 watt hours, I guess. So that's what the cell looks like. And I wanted to show you the method that I use for building batteries. So I made this little grid here, which represents the 52 batteries that I'm going to be using for this 48 volt build. And we can see that there's a positive and a negative side on each one of these battery cells. So each one of these sections is going to represent a battery cell. And the red is going to represent positive, and the blue is going to represent negative. So I have the positive side, and then I'm going to also have the negative side. So when building out batteries, we're going to flip them upside down, positive, negative, positive, negative, positive, negative, and so on until you get to the 13 strings. And when you build out a battery, you start with these cells. These are fairly low capacity cells. So they're 2500 milliamp hour. So I'm going to have to put 4 in parallel to increase these numbers from 2500. I need this to be 10,000 milliamp hours or 10 amp hours. So what we'll do is we'll stack 4 in parallel and we'll have them all on the same, positive to positive, negative to negative. We'll stack four of them in parallel this direction. And then we'll do in series positive, negative this way. So we have a 4P13S battery pack. As you can see here, I also built out positive, negative, negative, positive. So when we connect this up, we'll start with 0 volts on this first battery. It's going to be 0 volts down here. And as we travel through the battery, that's when the voltage is going to be applied on the positive side. So on the positive side, this is going to be 3.6 volts. So when we tie these 2 batteries together from here to here, this is going to be our 3.6 volt section. And then so positive, negative, that's going to be 3.6 volts. And then we'll travel back through the next battery, and that'll be converted to 7.2 volts. And we're going to do that all the way till we get to 48 volts. In this case, 46.8 volts with nominal voltage. This is what I like to do to just make sure that I have everything right before I'm going to build up my batteries. I did purchase 187 battery cells that we're going to use for 3 separate battery builds. So remember, a lithium-ion cell is 3.6 volts nominal voltage, but it can be anywhere from 2.5 volts to 4.2 volts. Now this is pretty important. So 4.2 volts, that is at the max range of this cell. So when we're talking about battery health for lithium ions, it's good to remember that 2.5 volts is fairly low. Generally, on any type of voltage with a BMS, we're going to be sitting around 3.2 volts or 3.0 volts is going to be considered the low voltage for a battery pack. So the worst thing you can do for a lithium ion cell is charge it all the way to that 4.2 volts. You're going to degrade your battery faster when you go on either one of these ranges. When you have cells in parallel, you're also going to increase both the milliamp hour and you're going to increase the amperage because you have them in parallel. They're working together. So if you put them in series, you're increasing your voltage, and if you put them in parallel, you're increasing your amp hours and the amount of discharge that a particular battery pack has. So in this case, we have a cell that's capable of 20 amps discharge, and it's at 2500 milliamp hours. So when we stack 4 of them together, we're going to have 80 amps of potential discharge rate and a 10 amp hour battery. Now I'm not going to use that full 80 amps. My BMS, or my battery management system, is going to be 60 amps max, and then when I actually put it on the e-bikes, we're going to be somewhere around 20 to 25 amps when it comes to discharge. So that's just good to know. But this is the layout of the battery that I'm going to use. Thanks for watching, and I'll see you next time.